Hey there, Hampshire chemistry students. Welcome back today. We're going to be taking a look in this video about polarity and how we can determine whether molecules are polar or nonpolar. So basically, polarity is the idea of describing how electrons are arranged around molecules, whether they're evenly shared or unevenly shared. If you have molecules that are unevenly shared or shared asymmetrically, we refer to those as polar molecules. Okay? So these electrons are shared asymmetrically, also known as unevenly. They create partial positives and partial negatives, like the poles on the Earth. So that's how we get the idea of the word polar. So nonpolar things are the opposite. These are atoms where the electrons are shared evenly around a molecule and you don't get any positive or negative charges involved. So let's take a look at some simple examples. So carbon dioxide is a molecule. Here is its Lewis structure, and of course its 3D model that we worked on earlier. So what I notice here is that the oxygen is a relatively high electronegative atom, and it's going to attract electrons to its side. But there are two oxygens in this molecule, so we're going to have two tugs on the electrons. It's like a big tug of war for the carbon's attention. But guess what? Both of these guys are pulling with even strength in opposite directions. So this is symmetrical, meaning that this is a non-polar molecule. Okay, they are evenly shared. Again, think of a tug of war with two evenly strength teams. One pulls this way with 100 pounds of force and one pulls this way with 100 pounds of force. Nothing changes. So we have a very simple non-polar molecule here. Let's take a look then at a different example. Let's take a look at our example for formaldehyde. This is one of the first Lewis structures we did together. So we can see here, and by its physical structure, that again, we have an oxygen that's going to be pulling its electrons away from the carbon up towards itself, right? It is a higher electronegativity atom. But we also have hydrogens. Now these hydrogens do have a little bit of pull as well. But if you look at the trends on the P table, it is going to be much, much less. So you can see we have a big pull up here and some little pulls down. This is asymmetrical or uneven distribution. So this is an example of a polar molecule. So I'm simply looking that there is no symmetry here vertically. Yes, there is some side to side, right? Because there's a hydrogen here and a hydrogen here, but there is no oxygen underneath to balance this out. So let's take a look at one final example, and that's going to be an interesting one. I've got here the structure C in the center. I want to have 3 H's. Let's do 4 H's here. Okay. So we have a tetrahedral molecule here. Remember, these guys exist in 3D space. So we want to think of it not as like a plus symbol, but as one of our tetrahedral models that we looked at here together. Now, again, we have some pull in our various different directions here, right? Each of the hydrogens are going to be fighting for the electrons of the carbon, but they are all evenly spread out. Now, again, it's not like up, down, left, right. We kind of have these pulls outwards and these pulls upwards. Now, when you take physics, you learn more about vectors, but essentially, because these are all angled out at the same angle, their down push is the same as this one up push, which is going perfectly straight up and down. So again, like with the CO2 molecule, we have some symmetry. So this is an example of a nonpolar molecule. Now I can change this very simply by, let's say, putting a halogen, like a fluorine or a chlorine on the end of this guy. So if I switched this guy to like a fluorine, now we have a much stronger pull in one of our directions. This would be an example of a polar molecule because it no longer has that perfect symmetry. So, in summary, you're looking for that idea of symmetry, of even or uneven sharing in our electrons. So, hope this helps you guys out. Okay, let me know if you have any questions, and I hope you guys have a great rest of your day. Bye-bye.